Alright, so here we're talking about the second derivative test. Now, the purpose of the second derivative test is to give you another way to classify critical numbers of a function as either a relative minimum or a relative maximum. And this doesn't replace the first derivative test, but it's basically another way of doing the same thing the first derivative test does. The first derivative test, recall, was a thing that would let you find out whether intervals were increasing and decreasing for the function, and that told us whether we had a relative max or min. The second derivative test is another way to do that, and it's generally faster. The issue with the second derivative test is that it doesn't always work. Sometimes it fails, sometimes it works. When it works really fast. And unfortunately, there really isn't any way of knowing whether it'll work when you start. So it really is just another method to do a similar thing. So the two steps, because there's only two steps. Step one, find the critical numbers. Find the possible maxes or mins. So then after that, in the first derivative test, we would have set up intervals, we would have gone through the other four steps. For the second derivative test, your second step is just plug these critical numbers into the second derivative and look at whether that answer is positive, negative, or neither. If it's positive, you've got a minimum. If it's negative, you've got a maximum. And if it's neither, it means the test fails. And that doesn't mean that it's not a max or a min. It means the test failed. You need to fall back on doing the first derivative test. You'll have to go back and set up intervals and go through that process. And I may have an example of that later. I don't remember, but I think I've got an example of that coming up. So let's take a look at the second derivative test in action. So here we go. I want to find any relative maxima or minima of this function, right? So if I'm going to find maxes and mins, I have to first find critical numbers. So I find critical numbers by taking the derivative. The derivative of this thing is 6x squared minus 6x minus 12. And I need to look at where this is undefined and also where it's equal to 0. Right. Well, because there's no division by 0, so it's not ever undefined. To work this out, I need a factor, so I'll pull out the 6, x squared minus x minus 2. I've got 6 times x minus 2 and x plus 1. Great, so my critical numbers seem to be 2 and negative 1, right? Now, if I was doing the first derivative test, then my next step would be to set up intervals from negative infinity to negative 1, from negative 1 to 2, and from 2 to infinity. But I'm not doing the first derivative test. I'm doing the second derivative test. And the way the second derivative test works, I guess I still want to use orange. The way the second derivative test works is you take these values, you take x equals 2, and you take x equals negative 1, and we plug them in to the second derivative. Now, you'll notice I don't actually have the second derivative. I need to write it down. This was my first derivative, right? This thing was f prime of x. So my second derivative, f double prime of x, is going to be 12x minus 6. So when I plug in 2, the second derivative of 2 is 24 minus 6, which is 18. Because this is positive, because the second derivative is positive, I know that f has a minimum at 2 comma, and we find that other value by plugging 2 into the original function. And if I work that out really quickly, let's see here. If we plug 2 into that original function, we're going to end up with, let's see here, that's 16 minus 12 minus 24 plus 18. I didn't think to work this out in advance, sorry about that. 36 minus 36, that's interesting, 2 comma 0. I'm almost positive I have an arithmetic error in there. But it looks good right now, so I'm going to go with it. Yay, so we have a minimum value there. Fantastic. I'm going to cover why that is in just a second. I will talk about that, so I'm getting there. Let's look at this other one. For other value, I need to do f double prime of negative 1. Well, keep in mind, I already have that derivative over here, so I just need to plug in. When I plug negative 1 into that, I end up with negative 18. because the second derivative is negative, it means that f has a maximum at -1, comma, and again, I need to plug that -1 into the original function to find out what that value is going to be. So that looks like it's -2 minus 3 plus 12 plus 18. That's 3025. And we're done. So, I hope you're impressed by the fact that this is a significantly faster and more streamlined process for finding maxes and mins. It's not a 5-step process. It's a 2-step process. All we have to do is find the critical number, plug it into the second derivative. If it's positive, you've got a minimum. If it's negative, you've got a maximum. Now, I want to briefly explain why that is, and it's really a very simple thing. What you need to do is you need to remember from yesterday, what does it mean if the second derivative is positive? It tells you something about concavity. If the second derivative is positive, it means your function is concave up. Now mentally picture, what does a concave up function look like? It looks like this. Right? What do you see right in the middle of that concave up region? There's a minimum. Like, it can't be a maximum. If it's concave up, it has to be a minimum. Similarly over here, if you have a second derivative that's negative, you are looking at a region that is concave down. And in a region that's concave down, you will never have a minimum. You will always have a maximum. So that's the idea that this test relies on. I've got one more example for us to look at, so we'll jump over there and see what we've got. So same deal here. I want to find any relative maxes and mins of this function. It's a fairly straightforward process, so I'd really recommend that you pause the video and try this one on your own. Like, make sure that you can get it. Your first step, of course, is to find the critical numbers. So I'm hoping you've done this and you're just checking your work. The derivative here is 5x to the 4th plus 20x cubed. We need to look at where this is undefined, which it isn't, and where it's 0. 5x to the 4th plus 20x cubed. If I factor, I've got 5x cubed times x plus 4. So it seems like my critical numbers are where this is 0 and where this is 0. So that's 0 and -4. So great, those are my two potential maxes and mins. I now need to test out what happens with -4 and what happens with 0. And the way I test that out is by plugging into the second derivative. So we should write down the second derivative. This right here was the first derivative, so I'll just take the derivative of that. This is 20x cubed plus 60x squared. And when I plug -4 into that, f double prime of -4, I end up with 20 times -64 plus 60 times 16. This is -1,280 plus 960. And what's important here is that this is negative, right? Because that is negative, because the second derivative is negative, it means we're thinking about a region that's concave down, and if it's concave down, it means that f has a maximum at -4, comma, whatever value we get by plugging that back into the original function. I'm going to skip over that in the interest of time. What about the other one? Right? What about when I plug 0 into the second derivative? When I plug 0 into the second derivative, I end up with 0, which is frustrating. When it's 0, it means the test failed. And what does it mean the test failed? It means that we need to fall back on the first derivative test. So how do we do the first derivative test? For the first derivative test, we're supposed to set up intervals, right? My intervals are supposed to be, from -∞ to the first critical number, from that critical number to the next, and from that one on towards infinity. But note, I already know what happens at -4. I already know that we ended up with a max here, which means I really don't need to know about this interval, right? what I need to know is what happens on these next two intervals. In fact, now that I think about it, it's really kind of interesting. Because this is a maximum, you know what happened on this interval. What happened over here? What happened is that the function was increasing. Why do we know that? Well, if I'm getting up to a maximum, it must have increased, then decreased. So wait, that's interesting. That means that over here, we know that f decreased. All I need to know is what happens over here on this interval. And because this is now the first derivative test, and you need to sort of make a note of that, this down here is the first derivative test that I'm doing. And the reason I'm doing that, of course, is that the second derivative test failed up here. It didn't tell me what happened. So I'm exploring that down here. To do the first derivative test, I need to pick a number on this interval, and I need to plug it into the first derivative. So first of all, remember what the first derivative is. The first derivative of this thing is, this was 5x to the fourth plus 20x cubed. And so if I pick a number like 1, f prime of 1, that gives me 5 plus 20. My first derivative is positive. Therefore, f of x is increasing here. If I combine that with the fact that f was decreasing over here, what does it mean happened at 0? At x equals 0, we have a minimum. Right? It's a minimum of 0, comma, when I plug 0 into the original function, I think I get negative 10. So this is our minimum. We had a maximum up here that I had the x coordinate of. I didn't plug it into the y coordinate in the interest of time. Just so that you know, you'd have to plug that into f of negative 4 would be negative 4 to the 5th power plus 5 times negative 4 to the 4th minus 10. If you're really interested in following all the way through, I'll see if I can do this in my head. That should be 1024. That should be 256 times 5, which is, it's 124 plus 256 more than that, and then minus 10. I'm this far. I feel like I'm committed. I have to. If you're still watching, you're my hero. Let's see. This puts us at 2304, and then subtracting 10, 2254. The chances of me getting that right this late at night are very slim. But negative 4 comma 2254. That sounds like a maximum. I mean, at least it sounds like a high value. Hopefully that made sense. We do have one more video in this sequence. That's about other ways that we can use the second derivative test. So perhaps I'll see you there. I checked my math on that, and indeed it was totally wrong because this was supposed to be negative. Given that was negative, I'm pretty sure that this number up here, still without a calculator, ends up being 246, which still sounds really maximum-y. Hopefully I got it right this time. Yeah, thanks everybody.